Welcome to question number 6 of our shadow paper from 2018, paper 2. So first of all, it says show that x equals 1 is a root. So what we're going to do here is we're just going to sub in 1 nice and clearly. Okay, and if it's a factor, then the idea is it should be equal to 0. So 1's very nice, isn't it? Because these things will just turn into 1's. Okay, and you can see it's equal to 0, and then we write a short conclusion. So x equals 1 is a root. And where's this question going? Hence solve. Okay, so while I'm here, I'm also going to write so x minus 1 is a factor. Okay, so the reason why I'm going to do this is I can spot that, well, if I just take those first two, do you see that seems to be some connection? And then if you keep going with it, yeah, okay, so it's a little bit, for the next one, it looks like, well, what has become what? X cubed has become y to the 6. So it's a little bit like the y bit is equivalent to what? It's equivalent to a root x, isn't it? Because if I substituted that in, wouldn't that give me the same? Yeah, so y to the 6 would give me x cubed. It's the same sort of thing. So what I'm going to do then is, if I'm going to solve this one here, well, what I'm going to do first is I'm going to factorize it. So let's factorize, and let's just use the original to factorize. So I'm going to use the table. So I'm going to say, if that's x minus 1, what would the other pieces be to take me back to this thing? So x cubed, I'll put a minus 5 in there. Okay, and the table goes something like this. So what we do is we write our quadratic at the top. I've gone a bit too far there, I notice. So let's just move that minus 5. So x times how many x squareds give you x cubed? Well, the idea is then you can work out that that's a 1. That's a 1x squared. Okay, and then you can use this. So 1x squared times minus 1 gives you minus x squared. And if we look at the x squareds that we're meant to go back to, it says 3x squared. The x squareds are going to come from these two parts. So I'm going to put a 4 in here. So I'm putting a 4 in here because together they add up to 3x squared. Yeah. So x times how much will give you, well, that's a 4 then, isn't it? Okay. And shall we do it one more time? I mean, you can hopefully see that c is 5, but let's just try the technique one more time. So 4 times 4x times minus 1 is minus 4x. And if you look at the x's together, it should add up to a positive 1x. So this has to be a 5x. And yeah, again, that also confirms the idea that this should be a 5. So this cubic at the start is the same as x minus 1, and then it's x squared plus 4x plus 5. Okay? Now, what's not obvious on this one here is, because we would normally try and break this one up here, but if you try and solve it, you'll see that it doesn't work. And if we do our discriminant, okay, so that's 4 squared minus 4 lots of 1 times 5, you're going to see here that you get a minus number, because you get 16 minus 20, don't you? That tells you, in other words, that this bit's not really going to go anywhere. It doesn't give you any roots. So it's only the x minus 1 part that's going to give you any roots. So that's kind of important for us to keep an eye on a little bit later. So let's now go back to this one here. So what did we say again about this? We said that y to the power of 6. So we said that y was equal to root x. So what we can do then is we can, well, we could do this maybe. And then it means that we could rewrite our factorization as over here, but we could do it with y squared. So we could do that. That's the same as y squared minus 1. And then this is all in terms of y as well, right? So this is y to the 4 plus 4y squared plus 5 is the factorization. And then it's got an equal to 0, hasn't it? Now, we know that this one doesn't go anywhere, remember? But that means that this one does go somewhere. So if y squared minus 1 equals 0, well, we could factorize that, couldn't we? So we could say it's y plus 1, y minus 1 is equal to 0. And then we can actually solve that bit there. So y equals 1, y equals minus 1. Because we know that this other bit over here isn't going to give us anything. Okay? And then it looks like we've got one more example of this underneath, but in terms of tan. So what's going on here? I'm comparing here. So it looks like x is equal to tan theta. Yeah. So for over this one here, so we're going to say x is equal to tan theta. Well, we've just been using this cubic, haven't we? So we know that the only one that leads to anything is this one here. So instead of x minus 1 equals 0, yeah. So I'm just ignoring the quadratic bit there because I know it doesn't lead to anything. So I'm going to look at the case of x equals 1 again, but I'm doing it now with tan theta when I sub that result in. So I just need to have a think about how many times tan theta is equal to 1 over this. That's three sort of cycles of tan, isn't it? So let's just think about the basic case. So that's from minus pi over 2 to pi over 2, which is pi apart. And I've got 3 of those in this bit here. And tan looks like this. Okay, so it looks like I'm going to have 1 per interval. So it says how many real solutions. So I'm going to say that there'll be then 3 solutions. Okay, it's not asking me where they are, but if I really wanted to talk about that, this is pi over 4. So, it's pi over 4, 5 pi over 4, 9 pi over 4, and so, and you keep doing that until that you're working in the right part there. Okay, so that's quite a common one that they like to ask you about, is doing some reasoning about something at the start and then extending it to similar looking expressions.